All right, good morning. We are in part 5 of designing a trophy truck with ClickRigs. And we are going to do some fun things today, I think. Obviously, we're going to keep working on the trophy truck, but we've got a little bit of a, it's related because it's related to a part, but we've got a little bit of a side quest. We're going to create a smart little parametric part generator. And yeah, so that's what we are doing today. Let me close that down. Let's jump into the browser and the CAD. As always, we are doing all this design work in Onshape, and that runs in the browser. So when pretty much on this live stream, whenever I say let's jump to the browser, what I usually mean is let's jump to the CAD software. Let's get this thing adjusted here. All right. Okay, so let's go do a quick recap of where we're at. We are working on actually, let's go to the overhead. We are working on a competitor to this vehicle, which is the MDRD01, which stands for the Mayday Race Desert version 1. And Mayday is the fictional, she is the fictional driver and builder and designer of this car, or this truck. And so this has been the sort of the highest performance kit in our store thus far, and I've been wanting to do sort of another trophy truck design to be a competitor to it for a while, and so that's what we've been working on all week. We're probably a little over 20 hours, or let's see, yeah, we're a little over 20 hours now into the design. If you feel so inclined, you can go back and watch parts 1, 2, 3, and 4, and this is part 5, and pretty much all of the every minute of the design that's gone into these things so far is available on those live streams. And I will be doing a sort of a highlight edit for people who don't want to watch 25 plus hours of video, but it's there. It's there if you want it. And so this is the TBRD01. It's the Thorn Buckingham Race Desert version 1, and it's going to be a competitor to the MDRD01. I've got the cab that I have on it right now is just cab and tail section, is just the Mayday cab. We're going to be doing a cab just for this vehicle, but it'll roughly be kind of the same dimensions, so I'm just kind of using it as a stand-in right now. We have started making changes to this tail section. We've added these bump outs, and so yeah, the bump outs pick up these braces, and that's these strut braces are related to kind of our little side quest for today that we're going to start with here in a second. But yeah, so we've added those bump outs to pick up these braces to sort of reinforce this tail section, which is something that the Mayday truck does not have. And so when the truck comes down off a hard landing and kind of like slaps the tail, sometimes it has a tendency to kick the tail off or knock the whole cab and tail section off. So the goal is to eliminate that from happening with these braces. And so that's kind of where we're at with that. The other thing we've changed is we've moved I'll show them both here, the spare tire from the top of the tail section to the bottom of the tail section. And what's kind of cool about that is it just lowers the center of gravity. And because the TBRD01 is a little bit shorter of a wheelbase, we can kind of tuck that axle in right behind, or right in front of the spare tire, so we have room to do that. And kind of at the end, we might even go in and add a silly little rear wing to it, just for fun. And so that's kind of where we're at. Let's jump into the CAD browser here again. And so yeah, so here's kind of a model. You can see the assembly with all of the components that we've been building. And the ClickRig system is it's a modular system. So it's kind of like Legos in the fact that all these parts are designed to be able to click into one another. And so you can mix and match parts, and you can build different rigs, you can create your own, you can modify rig kits. And so, every rig kit is going to be kind of a combination of some just parts from the catalog and then new parts that we make just for that kit. And then those new parts can be used again in other creations. So that's been a primary goal of mine in designing this whole system. I mean, most of the work has gone into just kind of creating the modular system. And then I feel like it's finally at the stage where now we're going to be releasing a lot more kits. We're going to be live streaming this, every weekday, and we're just going to be making more and more rad rigs. So that's and getting everything to work kind of in the modular system has been one of the challenges and also one of the fun parts. But I think we've got a really rad setup here, and it's becoming quite fun to design with. So this is where we're at so far. This is 20-ish hours into the design. We are at this stage, and yesterday where we left off, I've been wanting to reinforce this tail section for a while. And kind of came up with the idea of doing it with these flexible struts that are really similar to kind of like a suspension link, except for they could articulate, so you could actually reuse these to create kind of your own link type suspensions. But in this application, this body and this body are fixed in space; they don't move, and so this strut acts just like a brace essentially. And this will be the first kit that kind of has this. I did something kind of similar in the long travel kit for the Flying Pancake, which is sort of the most basic low performance vehicle in the ClickRigs lineup right now. But I thought it'd be fun to make a bunch of modification kits. So it's kind of like the Honda Civic of the ClickRigs Harley Dome world. And so there'll be a bunch of kind of stupid but also super rad modifications for it. And one of those modifications is a long travel kit for the Flying Pancake. And you can kind of see here, so we can make that bigger. This cab brace is actually just the triangulated 4-link connector from the Mayday trophy truck. So this is basically part of the 4-link rear suspension, but we're just repurposing it here as a cab brace. And so that was, I guess, technically the first use of that, but this will be the first kit that sort of has that as its own dedicated parts. And I'm envisioning a lot of potential forward use cases for these struts. And yesterday, I kind of struggled a little bit with how to design these, because you're kind of connecting points in space. Onshape doesn't do 3D sketching, which I don't think is a huge problem. I just haven't done a lot of kind of design with it where I was trying to bridge between a couple spots. And so we did a number of things. Let's see, I think in here, let's just show all these parts. So this is the one of the design part studios where we're kind of designing a lot of the one-off parts. And here we kind of designed this, and just kind of, so we made a plane, and then a bunch of sketches, and but kind of after that, and after we wrapped up, I had kind of a thought that there's a much simpler way to do this, and so that sort of started with, okay, I want to be able to easily generate kind of a strut to connect any 2 points kind of in the ClickRigs grid. And so the thought that I had was, okay, well, all I really need are 2 dimensions, and one of those dimensions would be essentially a straight line distance from the center of, well, let's go to let's say this connector, the center of a connector that we want to connect to the other one. And so you can, in the assembly, you can just select those two, and then this gives you that center distance. So in this case, it's 50.00136 millimeters. And so you can just copy that again to kind of show that's the straight line center distance. And then the second dimension that you need is the height. So again, the ClickRigs system is built sort of, it's like a layer cake. So from the top, everything's built on a 10 millimeter by 10 millimeter snap grid, and then from the side, everything's built like a layer cake in a layer system. And so you've got, and this is a recap, but I'm going to go over it again for people that are new. And you've got the chassis. So we've got four primary types of components. You have chassis components, which are, it's essentially the center line, the vertical center line of the system. And what defines a chassis is two parameters. One, it's 10 millimeters tall. So from here to here, it's 10 millimeters. That's a little bit shorter because there's a chamfer, but the stack height is 10 millimeters, and then it has a snap dot receptacle on both sides. And what that means is from the chassis center line, you can either build up or you can build down. And then you have the other type of component, which I actually don't think I have any in here. We'll jump over into the model catalog and I'll show you there. So the other type of component is a connector, and a connector is also defined by essentially two parameters. That is, it is 5 millimeters thick, so half the chassis height, and it has a snap dot receptacle on one side and the snap stud that goes into that receptacle on the other. And what that means is you can snap connectors on top of or on the bottom of a chassis component, and you can just keep stacking as high as you want to go, or as low as you want to go. And then the third type of component is a cap, and a cap is it's essentially any component that breaks the grid system. So this would be a cap component because it's got a let's isolate this here. It's got the snap stud on one side, but on the top side there are no more snap receptacles, and so you can't snap. Once you put the cap on, you've terminated being able to build in that direction, in that space. And then something like this tail section would also technically be considered a cap, even though it's got some snap receptacles in it. It doesn't follow the grid, so you couldn't snap any other part onto it. And then the fourth type are things like springs and basically the articulating components, the suspension components. So those are our three types. We've got chassis components, which are the center line, and you can build out in the up or down direction. You've got connectors, which you can just keep stacking, and then you've got caps, which sort of finish off the build in that layer. And so with that, to generate our stud, we need that point-to-point distance in the straight line, basically the center line of where the two snap connectors will connect. And then we need our stack height. And so, in this case, this one would be from there essentially to this height. And so our parallel distance, which you can see down here, is 30 millimeters. And pretty much everything in the system is going to be an increment of 5 millimeters, because that's what it's designed around, but that's a function of the chassis and connectors being 10 millimeters and 5 millimeters respectively. So that being said, if we want to connect any two points in the ClickRigs grid system with a strut we just need those 2 dimensions, as long as we build sort of our model and our generator correctly. And so my thought was, I could build a generator model that just takes those 2 things as an input and then automatically generates a strut, instead of going in and kind of having to build a bunch of planes, because you all know how much I hate making planes. They're like a necessary evil in my opinion. I could just build a model that generates that mostly automatically and quickly, just with those 2 dimensions, which is super easy to pull off of an assembly. And so I've kind of started that. It's not complete, but we'll jump over here into the strut generator, and I can just kind of walk you through. So here's a, I think I copied that. So let's see. It was technically that dimension. And so let's just step through this here. So we've got a few variables, and that's how Onshape works. You basically create variables. And I learned a couple things doing this too that I was not aware of, which I'm kind of excited to learn. So we'll get into that. So you can go up here, you can create a variable, and you just drag it into your tree. And it is time-based, so depending on where it's at in the tree is sort of critical. So for a lot of these parameter style things, I like to throw them at the top of the tree so that all of the features in the tree have that available. And so let's start. We've got a length variable, and this is a name. You can type in whatever you want. So you do have to make sure that there are no spaces. So there are a few little requirements for the name. You can just use an underscore though. But in this case, this one's called length. It's a number, and it just allows you to enter the value. So we've got our 50.00136. And then we've got another parameter here, which is just the height. So these are our 2 input parameters. I have this one set to a length. It's okay, it could be a number, but we're going to work with some lengths later. And so yeah, so that's again height, enter a value. Those are 2 input points. Now this is where this one gets, in my opinion, mildly tricky, and there might be better ways to do this, but this is the way I've done it now. I've created a sketch essentially to just do some geometry calculations. So, and let's just rename that now. Since we're building a generator, we're going to use this, so we want to make this model clean and not dirty. I'm just going to call this geometry calc. And so let's jump in here and see what this thing is doing. And so this is really, and if anyone was watching and caught last stream or the one before that, I forget which one, where I talked about I love the 2D sketching of parametric CAD. Just being in a 2D sketch is actually one of my favorite tools, because you can actually solve a lot of interesting and kind of sort of model a lot of interesting geometry and linkages and mechanisms just in the 2D space using most sketchers in a parametric CAD tool. And I do wish that those were available like as a phone or a iPad app, just standalone, just something super fast and light that but had all the power of the relations and the dimension and the equations and functions that you can build into a 2D sketch. So anyway, this essentially we've got a few lines here, and so this line right here is 9 millimeters long, and it represents essentially the diameter of the snap point, one of your snap points that you're going to connect the strut to, because those are 9 millimeters in diameter. So the center point of that is essentially the center of that circle, and the flat part of the strut that sort of gets clamped between a connector and a snap receptacle needs to essentially be flat for that 9mm diameter before it is going to then bend to wherever you need it to go next. And then the same thing here, another 9mm long line with the center point. And so now we've got this line, which is essentially our straight line distance between those 2 points. And that line is the same length as the measurement that we got by clicking kind of on the 2 circles that we're trying to connect. And so when we punch in the value in our length variable, this line references that. And so you can kind of see we've got the length variable. And so that makes that this length. And so these 2 points will move depending on that. And so we've got our 50.001. And then this, the offset or the parallel distance between this line and this line, is our height parameter. And so again, this one takes in the height. That's 30. And so now what we've done is we've essentially created a 2D version, or the same thing that would have been on the plane that we created, that's driven by this length and this length. And so, and then we use this sketch to calculate this dimension. So this is a driven dimension, and it's this line right here that we care about, which is effectively the distance from the pivot points that we need between those 2 points that we measured on the assembly. And so that's obviously going to be shorter, but depending on this height, it's not necessarily going to be shorter by 9mm, or this distance and this distance, because that changes with the angle. And so effectively we're just using the sketch as an intermediary to calculate this this dimension. Which brings us to our straight length. And so our straight length, and this is something that I learned. I did not know you could do this until yesterday. The straight length is essentially another variable that we pull from that sketch. And what's a little bit interesting, I would have thought you could just sort of click on that driven dimension and just bring that value in. You can't. And so I was trying to find a way around that limitation, and then I noticed that up in this in this variable, we've got kind of 2 tabs. We have assigned, which is basically the one I've always used, but then there's this one called measured. And so you can click measured, and then you can click like distance, length, diameter, and then you can choose entities. And so what I did was I just chose the 2 points created by that line in that geometry calc sketch, and that results in a value of that length. And so now we can create another variable, which is essentially a little equation. And so I pull in the straight length, and then I add 9mm essentially, and that gets us back to our flat overall length between the 2 points. It's a little bit convoluted, but it gets you there. And yeah, we're nerding out in some CAD. And so then we create another variable, and that's let's double check here where I'm at. Yep. So that calculated length is the length between our 2 kind of like snap points on a flat printed component. And then we've got this, which is super convoluted, but it's basically, it then calculates from those calculated lengths, it's called snap spacing here. It should actually be called snap count, because it's coming up with how many of the little connecting snaps between the rigid part and the flexible part do we need for that length. And so, I mean, here I just have +1 because it's starting with a center bit, and it's going to add them symmetrically. And then I'm using floor, essentially just to turn a decimal value into an integer, because you can't have 7.2 snap instances. You can have 7, you can have 8, or you can have 6, etc. And then I'm just taking the straight length, and then there's some kind of funky stuff going on here where it's like divided by millimeters plus tolerance dot zero length. That's just, it's essentially because we're applying sort of a floor function to a length, something that Onshape knows is a length, and I don't know why, but that's what I found will make it work. So essentially we're turning that length divided by 12, and it's divided by 12 because I want a 6 millimeter spacing in between the snaps, but because we're doing it symmetrically, I only need to give half the instance count, and so I'm dividing by 12 instead of 6. So that gets us that, and so now we can move into our sketch, which let's call that I don't know. Let's call this the primary sketch. That's going to drive everything. So now we go into here, and we have our first sketch that's actually giving us some geometry. And this is going to generate essentially the two components in their flat state that can be manufactured on the printer. And so we've got a couple, we've got some hard-coded dimensions. We've got 4 millimeters for the hole, 6 because that's about the size that I want these to be, 4.5 from the center to this line because that's about how much thin area we're going to need to make sure that the strut can bend. We've got a 6 millimeter width because that's about as small as I think it can go for both structural and for printing reasons. Then we've got this hole which is centered between the two outboard ends, and that is that's going to drive our snap geometry. And then essentially we've got this, which is just the calculated length that we got to in our convoluted way over here. And so that sets essentially the length of this whole component. So as you change your length and height input variables, this will change the sketch to match the length between this point and this point that you need. And then we go in and we have our first extrude. I'm just going to, I'm going to clean this up as we go. So that's going to be our thin TPU extrude. And I know these have little icons and tell you what they are. I like personally to add in the feature type just directly into the name sort of manually. I know that's redundant. That might annoy a lot of people. I find it helpful. So there you go. And so this first sketch basically extrudes our thin section, which is just 0.8, so 4 layer lines thick, and that's going to give us kind of our hinge points. Then we're going to go in and we're going to extrude the thick section, and so let's rename that thick TPU extrude. And we'll just work through this. And so this one adds our rigid stiffener component, and we're going to we'll rename that. Stiffener extrude. And then I'm going to see while we're at it, let's rename these parts so they're meaningful. Call that strut TPU, strut stiffener. Okay, so I'm going to hide the TPU component right now. And so this next extrude, this next feature, is going to add a single snap. So we're going to call this the stiffener center snap extrude. And then the way I've done this, instead of patterning it in the sketch, which in Onshape can be a little bit wonky sometimes, I'm actually just extruding it, and then I'm going to do a feature pattern and just kind of add the bodies to it that way. And so that's what's next. So boom. Let's rename that. stiffener snap pattern. Like a tongue twister. And so that adds that there, just like that. And then the next thing we're going to do, I'll just swap these here. We're going to use a Boolean to essentially make our snap geometry from the other part in this part. And so, and we'll rename that snap Boolean. And then we've just got some cosmetic fillets. And that right there is our two components that we need. So we could print this. In fact, that's what I used to print this one right here. And so the fit was perfect. And so I am quite happy with this. And what's nice now is, just like the other component generators and the chassis and cap generators, we can just put this sort of in the main generator document and copy this tab in whenever we need to do one, and then just generate a new thing. So what I would like to add, one way we can make this a lot more useful and save us a lot of time, is this. Again, for these compliant mechanisms, most CAD packages that I know of are not good at letting you design with compliant mechanisms. So you sort of have to hack it a bit by essentially either designing it in its folded up state, cutting it up and then flattening it, or designing it in its flat state, cutting it up, and then making a version that is in the bent configuration. And so in this generator, what I would like to do, in this case we started with the flat manufacturing model. What I would also like to do is have it generate a bent up configuration just as a separate model, so that we can pull that into assemblies and use them just for fit check, renderings, etc. And then so in this case, this one is actually the original one that we did, and that one I designed in the bent up state and then flattened it, and so that's why this is this way. So what we actually want to do, I want to have the generator automatically generate a model that is in this state, so I could bring it into the assembly as it is and do it from there. And then there are a couple of ways I think we could do that, and I'm not sure which one is going to be the best. One way, we could essentially take our flat component, sort of like we did with the A-arm assembly, which we also designed flat and then cut up and then bent up. So we could just take our flat model, essentially in the generator, create a copy of it, and then split it and then bend it. Probably, let's go into there. Probably using angles calculated from this geometry calc sketch. The other way is we could actually model it as, we could just do another model based off this sketch as one piece. I'm actually kind of liking the slicing it up. And what I'm wondering is if instead of even automatically doing those angles, we could just add pivot points and then make this like a sub-assembly that has mates, like a revolute mate. And that could be, we're going to try that and just see how that works, because that would actually be more powerful, because then you could use these struts in sort of dynamic linkage assemblies as well, not just static kind of strut bracing like we're using it here. So let's see. Trying to think what the best way to do that would be. Because what would be nice, I don't know if you can, it would be nice to have it as a sub-assembly, so you could just insert it into into your main assembly and have it just already be together. I don't know if you can do that in a part studio though. Well, let's start by creating. So what's the best way to do that? I wonder if we just duplicate that. Actually, I kind of want to do both of those. Actually, I don't need both of those. Let's just go to the top. Let's just call that 30. So essentially I'm just using the transform and selecting copy part to make a duplicate that's just a little bit offset so they're not overlapping. So now we've got a duplicate of our component, and we're gonna try to keep this model nice and clean as we go. We'll call this articulating component transform. We'll call it duplication because that's functionally more what we're using it here for. Again, I'm just naming these so that it's like, you know, if I haven't looked at this, been using this model, let's say for months, I come back into it and, you know, it's like jumping back into someone's code. You have no idea what's going on, even if you're the one that wrote it. You're like, who the hell did it that way? What a dumbass. And so this just kind of helps you understand the reasoning behind it. It's like notes. It's like a little notebook that sort of documents your thought process and how you got to where you got. I can't tell you how many times I've jumped into one of these that was documented poorly, and I get like, oh man, why did I do it that way? That's stupid. And then only to get like, you know, 2/3 of the way down, it's like, oh, that's why I did it that way. Okay, I'm not so stupid after all. New me is more stupid than old me. Sometimes that's just how it goes. So we're gonna try to keep this model clean and see if we can make it so it's nice to use for our future selves. And I know we haven't been doing a lot of we haven't been focusing a lot on the rigs. So if you're watching this and you're like, let's just get to the off-road trucks already, we will. But also, you know, the ClickRigs system is designed, if you've got a 3D printer and you want to jump into CAD, I mean, Onshape, I'm pretty sure still has free account tiers. You can design your own. I mean, I would love it if people started designing their own sort of modifications for these rigs. And so, you know, if you watch these videos, we're gonna stream the entire design process for every single new rig kit in the store. And so you could plow your way through those, and you'd know how to design parts for your rig. So that's kind of what we're doing. If you watch all these, you'll have a pretty good handle on how to do some 3D CAD design. So what we're doing is we are going to slice this duplicate up so that it's in components. And the trick is we're going to need to make it so that it's like accurate. And so we're operating on a 9mm dimension, which means 4.5 from here. What is that? Center distance. Yep, so our center distance is exactly 4.5, which is good because that means we're essentially putting the pivot right there at that line. I'm kind of curious. So we're going to use the split tool to kind of chunk this up. And we're going to split this component. And I'm not sure you can split with a line. You can't. So, all right, that probably, maybe there's a better way to do this, but that probably means we're going to have to create a plane. And you know what I think about planes. Let's call this split plane A. And we're gonna do line angle. We want that to split at 90. And we're going to have to create another one there. And we'll just call this split plane B. Alright, so we've got our two planes. And so I'm going to hide them because I don't like looking at them. We'll just select them in here. So now we're going to go to the split tool. And we're going to select our component and we're going to split it with split plane A. And we're going to split that again. We're going to split this part and we're going to split it with split plane B. So now we've got three components. This one, and this one. So let's do a little cleanup. We'll call this split A. Call this split B. And then let's name these parts. This is going to be strut connector A. Strut connector B. Let's call this strut. So now we've got those components, and I don't think there's a way to just kind of like build in a mate. If anybody's watching and wants to tell me if there's a better way, but I think we have to create a secondary assembly in order to make this a subassembly. But what we've just done is we have taken this flat component and then we have split it up into three pieces so that we can make an articulating version of that. So I am just going to go in. Let's just create a new assembly. If there's a better way, we'll go in and redo this. And again, we're keeping this model clean. So we'll call this the strut. Let's capitalize it. Call this the strut generator assembly. We are going to insert strut connector A, strut connector B, the stiffener, and the strut. So now we've got kind of all of our components. And we're going to introduce a mate. And so before we do that, we kind of need to figure out where to put the mate, because that will actually throw the geometry off. Let's go into our geometry calc sketch here. And so we've got I'm just trying to figure out which way the offsets go. I mean, in theory, this is probably like center line. So I'm trying to figure out, let's see if we go into the assembly. We've got kind of this component here, and we can kind of pivot it. We could pivot it between these two. We could pivot it between the top edges, or we could pivot it around the center. Let's just start. Let's pivot it around the center. So we'll add a revolute mate. Nope, not that way. That way. That way. Do the same thing here. Let's see, I'm going to add just going to basically reference it to the origin here. And then we'll do a fastened. We'll do the center one because that's always going to be there. Pretty sure. Okay, so now we've got something like that. We could add a parallel mate for like a static style connector, since they're always going to be connected parallel to one another, but this is more useful. And so I'm curious, this, in theory, this one now should fit. So let's I wonder, can we create a group? And just call this articulating strut. Doesn't like it though. Oh well. Maybe group probably just makes it static. So let's see. Let's just try bringing this in and see what it gets us. My concern is that if you try to mate, what I'd like to be able to do is reliably just do a fastened or a revolute mate, or even a ball mate, which would be another way to do it. We could do a ball mate. Let's just try a bunch of stuff and see what happens. So let's jump into here. Let's insert. We want to insert assemblies. So that's the assembly we've just created. And let's see, experiment with some different ways to mate this up. I guess let's try the revolute. We don't want a fastened mate because that'll sort of force the rotation as well. Let's start with a revolute and see what happens. So we want to, we can clean this up too so it renders better, but for now let's just make sure we got the geometry right. So that's going to go there and there. So now we've kind of got this. We should also be able to. And so what happens, in theory, what we should be able to do is do another revolute here and here. Can we solve for that? Doesn't like it. over defines the assembly. So let's hide these components here. Okay, so kind of what I was worried about is, and this isn't totally a big deal, but it's probably because we went to the center, and really one needs to be one direction and one needs to be the other. So let's jump back into this. Let's just redo a couple of these mates here. Maybe we just go opposite, opposite. So let's hide this here real quick. Okay, so here you can kind of see where we're just flip-flopping the side that mates on and see if that gets us back to something we could use here. So does a revolute work now? No. But why not? I'm just gonna hide everything else for now. Oh. Okay, so let's jump back in. Let's try one more thing. We're going to make these mates on the same side. Let's see what that gives us. Did that update? I don't think it did. Let's we might have to create a version here. Okay, so back in here. Sometimes it can take a couple minutes for that looks better. Let's see if we can. Oh, we don't want it fastened. Pick the wrong one. Nope. Okay, something else we can try. Let's just go delete that. Let's try a ball mate. Just because I'm curious what happens if we do a parallel. Okay, that works. So now that is pretty fully defined. Everything hits where it needs to be. And what's nice too is in this orientation we get overlap, and that's essentially how you trick, you know, for rendering purposes, so that you don't have like weird gaps. You can basically just do your mates so that these surfaces overlap, and that will render nicely. I've even done some things where I've like designed a little sort of semicircular piece of geometry, a little tail that doesn't really need to be there, but it just ensures that there's always some overlap. You know, and that's not obviously the real thing would kind of have an arc to it, but again, for a lot of the rendering purposes, that's just fine. So let's see, let's actually insert another one. I think we actually want that to be the stiffener facing the other way, so let's see if we can make that work first. So what did I do? I did ball mates. Let's do they're always a little wonky. And then let's do our parallel mate. There. Doesn't really matter. I'm just going to fix this real quick. Fix it in place. Not fix it as in repair. so that we can So in some ways, I think I liked going off the center line of that better. Let's see what happens when we go back in and sort of redefine that. Probably going to break all of those mates, but that's alright. Oh, I didn't. Although, do we need to? Okay, let's just kind of let's start from scratch here and just see what we get. I'm also curious if we mix. We're just experimenting right now, so if we and I guess in theory this should come into the center line. We can kind of change this to but my guess is the revolute will not work. Nope. But I was wondering if we did a revolute and a ball combo. Are we fully defined there? Almost. Kind of curious how that matches up. We got a little bit of interference. And that's true here, but as is often the case, especially with kind of like smaller designs, what looks like a massive amount of interference in CAD is actually quite minimal and sort of easily accommodated by the real world nature of materials. So we're kind of looking at the sort of interference right there. But at least here you can kind of see and determine if that's an issue or not. The other thing we could do, again, the part of it too is the flexure here is going to be slightly different than the real world, because these will flex differently. It's not a hard crease right at that point. But let's do this one that way and just see. Let's show these mates. We're just going to remate this, so kind of get this roughly oriented here. So if we're not too far out of whack, give the solver a nice fighting chance. And just use kind of the fix and unfix temporarily to sort of get the component roughly where we want it to be. And so let's see, the strategy we used for these was a revolute on 1 at the center. I think I did not select the right component. That looks better. And then we did a ball. Same thing, center, and on here. We get kind of a toggling effect. Curious what happens if we add a parallel mate just for grins. That does work, so let's add it to this one, just to keep weirdness from happening. It's interesting, because it didn't like that. I wonder why. Alright, I'm going to go into the strut generator, and we're going to, remember I was talking earlier about kind of creating geometry to sort of make sure there are no gaps. We've gone and used a center pivot here, and so what we can do, let's just create kind of a spherical, let's hide these two here real quick. Just going to create some spherical, basically a circle nub that kind of sticks out so that there's always interference. And this is kind of a, we'll call this gap eliminator sketch. And this one should be pretty simple. So we're just going to kind of do a circle there and there. I think this will work. I'll do one here as well. Super easy. Then we're going to extrude this. Let's call this gap eliminator. Gap eliminator extrude. And again, we're just keeping these clean. And we're going to add this extrusion. And we're going to add it to this part. And we're just going to go up to face. We're going to choose this face. Just like that. And now, essentially what we've created is just a little nub that should always stick in, but that might have broken our mate. So let's go in here and see, sure enough. So we're just going to have to fix that. Easy enough. And so again, we want that center revolute. And the difference is we just lost our geometry reference, but it should be right there. And so now, let's go fix this one. As these bend, we're always going to have overlap. Hey, buddy. Which will work great for rendering. So yeah, so that's a little trick when you're creating kind of some components that need to sort of simulate, at least visually simulate, compliant mechanism and kind of bendy parts. That's kind of a quick and easy way to do that. And you could get a lot more complicated. I mean, we could sort of like do some test prints and actually bend the components and kind of get a a good idea of the bend shape, and then go in and actually model those curves and get probably a fairly close approximation. But for this purpose, these are really just kind of fit check, and then so I can render these out easily later. And so that's where we're at. Let's show everything else. So I'm definitely liking that. And that'll make it easy. So now we can kind of generate really strut connectors or links to individual links to connect all kinds of stuff. Like if we wanted to, in theory, we could make this triangle link. We could just have two separate links that just kind of overlap and meet up there, and that would accomplish the same thing. In this case, it'd probably be a little bit less stiff side to side, but from a geometry standpoint, two links coming to the same point are going to be exactly the same as one link. All of the side to side, or most of the side to side stiffness of this axle location, which is provided by this link, doesn't come from the rigidity of the connection in this space. It just comes from the geometry of triangles and links that are stiff in compression and tension. And if you're interested in learning more about that, just kind of look up essentially space frame design, or just look up what a space frame is. It'll tell you all about that. You get to learn about nodes and tension and compression. Okay, so that was our side quest, I think, for the day. We've kind of created what hopefully will be a useful tool, and I'm sure that will get refined as it gets used more. But for now, it created a couple nice struts that will work. The geometry has been verified on a real model. What we should probably do, let's print out a few more. Let's get a few more of these printing. Now I can't pull that one, so we're going to go back to the strut generator. And before I do that, hold on, gotta go take a quick break, and I'll be right back. Although, yeah, let's get these printing first. So we created the strut generator, and now export these. Jump over to the slicer. Split this to objects. Let's just do an extra set. And get that printing. So we'll get those components printing, and then come back, we'll install them on here, and then kind of, I think, keep working on this tail section a little bit. We need to kind of refine the connector that we were working on yesterday at the lower end of these two struts, and I'll probably add in some provisions to connect the limit straps to the axle. And so, yeah, do that. Let's see. There we are. Okay, I'll be right back. All right, we are back. We just got a couple struts made with the new strut generator printing. I'm not waving at you. I'm just turning on the AI camera so it tracks all my movements. Let's see. Let's jump back into the CAD here. All right, so this is where we're at with the new ClickRigs trophy truck kit that hopefully will be available for sale. I'm shooting for next week. We're going to try to wrap this up by by the end of next week. We're what are we at? We're an hour and a half in today, so we're probably like 22 hours roughly of design time in this thing so far. Let's see if we can kind of wrap it up around the 40-hour mark. So we just did these stabilizing braces, these two struts, and now I think what I want to work on, let's just kind of isolate some stuff here. So I think what I want to work on right now is this this connector, and it has some interference with the rear four-link, the upper four-link mounts, or upper four-link links. And so I think instead of putting the snap dot connector here, I'm going to move them inboard to here, and then kind of just have this be a thin little tab. So let's switch to that one. We're now working on this piece. Let's kind of control back to here. And the way some of these generators work, I'm going to show all these parts here. We've got these plugs essentially, which we use to just cut pockets out, and that's where the snap dots go into. So it's easier than just modeling it in every time. You just create this plug, bring it in, and do a Boolean operation and to subtract it. But we are going to move. We're not going to do these anymore. We're going to do, if I can select it, this one and that one. And now we'll just hide other parts. So now we've got our snap dot pocket right in there. Just need to reselect some of this geometry. Okay, but all this stuff, so I'm pretty sure we just want to delete all that. Okay. You know, we might as well just keep that there because. So let's go back in and add this one as well. Okay. So now what we're going to do, we're really only picking up these two, but it doesn't hurt to have that one there. Add that back. And so what we're going to do, we're going to just kind of trim this down, sort of like that, to create clearance and a hold down. So let's see. We're kind of using this in an upside down state. So let's just do a new sketch. I'm just going to give myself a center line. I'm going to switch to translucent here just so I can kind of get a rough idea of where the pocket geometry that I need to avoid is. We're just going to kind of essentially do something like this. Sometimes it's easy just to kind of rough out the pocket. And then we can kind of add some relations. And I know that this angle here is 45, so it was designed for printing. So we're just going to kind of, we want it to be parallel to that. So we can define that. And so now we've got a couple sort of I guess, functional design dimensions to add. So one of the critical dimensions will essentially be that one, and that's going to be how thick, oops, maybe somebody's at the door, how thick our hold down tab can be. Let's start with 2, and just kind of, the other thing too, we might add a little cutout. Let's go 2.6, make it a little stiffer. Start there, and then this we can get pretty close. Let's go 12. That's probably good. The closer we get that to this pocket, the more clearance we'll have from the forelink that we're trying to get rid of. Let's see, let's do, and what I'm doing here is I'm just creating a clearance, or that 0.8 thickness of the strut that we're connecting. And then we're just going to remove all that. And I'm pretty sure this can be 9. That might print a little funny, so we'll see. We'll see how it goes though. And then we can just mirror that and remove through all. Okay, well, it's not quite done, but let's throw it into the assembly and just kind of see where we're at. Oh, it's already in there. That's right, the mates there were. Let's show these mates. I'm just going to bring this in again. Insert this. Do a fastened mate. Just like so. Again, we show a little bit of interference here, but that's just because we're only approximating the way this part bends. In reality, there actually is clearance. At some point, I might go clean up this generator, but for now, it's fine because again, the accurate part is in the flat one that we print. This is just to give us something we can render and just generally check for fit. Let's bring in the let's just show everything here. So kind of in the full droop mode, that's roughly what we're trying to eliminate as much interference there as possible. Probably round that and get rid of a good bit. Couple things. Let's just fix this real quick. I also think we're not going to be able to make this work just from a printing standpoint. Let's get rid of that. Let's take a look at the translucent. Plenty of clearance there. See how that looks? Much better. This is a slightly over droop condition, but we're just barely kissing it. Okay, so we're just dealing with packaging issues. There's, not a lot of room in here. We've got this thing that moves up and down. Let's hide this cab because that's not relevant right now. And so we need a way to secure these struts to support this tail section, but have enough clearance to let this whole thing cycle. So I think that part's pretty good. Let's go ahead and let's get this part printing. Looks like our struts are done printing, so we'll pull those off and get these going. Those two, and those are the stiffeners. And we've got flexible bits. And so the way these work, they basically get your flexible strut, obviously too floppy, so then we add the stiffener. They should just snap right together, just like that. And let's go in kind of right there to stiffen up that tail section. So let's go ahead and we're going to get this hold down for these printed, and then we'll assemble the whole thing. So let's see. Let's jump over to the slicer. This is our collection of all the new parts that we're making. I'll just move those off for now. Those are going to replace these. Let's import our new hold down connector, which should be there. That is going to be the PLA Pro. Those settings are all good, so let's slice that up. Let's take a quick look at it. Good. We'll print that. get that going. Okay, so let's jump back into the CAD. That's my dog. Do you want that? Not now, buddy. You just lay down. Okay. So I'm liking what we've got so far. I think maybe while those are printing, we'll jump in and we'll provide, we need to put in some provisions to pick up the limit straps. I'll kind of show you here. So this is a new one we're working on. This cab is going to change, but the, it's going to have limit straps similar to that, and these are adjustable. You can just kind of thread it through like a belt and change the length, and then they pick up here on the bottom of this axle truss, which this one will have, which we should actually print some of that too. But unlike this one where the limit straps are kind of an add-on, it's going to be built into this rig, and so we just kind of need to provide these slots in this tail section somehow. So let's figure out how to do that. This geometry works pretty well, so let's find that part in the model catalog. Jump over here. The ClickRigs system is modular, so all the parts kind of can be interchanged and click together to build different things. And then every time we do a new kit, it's kind of a mix of existing catalog parts and then new parts. And then all the new parts we design go into the catalog, so there's this growing repository of parts. And those get stored in here, so I just need to find, it's that one I believe, CR46. Let's see, so maybe let's jump back into here. Let's hide this plane. One way we can start, let's just kind of rough it out and see what we're working with. Let's bring this part in. The documents, go to the model catalog, and what do we say, CR46. Yep. And we'll just bring that in. It's over here. Let's just transform that. We'll do it by make connectors, try to get it somewhat close to where we want it. Let's see what. Do a center. That actually doesn't look half bad. We don't really need this cutout there anyway, and I'm probably going to add some more snap dot connectors like up here out back so that we have a place to snap on our silly rear wing that we're going to do. So I'm not actually opposed to that. Let's let's just hack this up here. We're just going to do this in a really dirty way, but that's okay. Let's do a symmetric. That one doesn't really matter. And so now we can kind of again, this is super dirty, but let's it's a good starting point. And I think there's a tool in here. I don't use it a whole lot, but I think there's a tool we can kind of remove face that might get rid of. Does that work? Use that for getting rid of chamfers. She'll just make it a little, get rid of these chamfers, makes it a little easier to integrate into the tail section body, which is what we're going to add these to. That way we don't have to, we know this works really well, that way we don't have to redraw it. What are you barking at, bud? Okay, and let's show that. I'm kind of oddly really liking the way that looks. I think that'll actually kind of flow neatly into our wing section that will be back here, just like from the top. Hey, no barking. One thing, so we're going to have to nip that off a little bit because that interferes with our snap dot pocket. Let's go back into that sketch. Again, we're just gonna Boolean these together, so all of this crude hacky nobody will ever know. That's what I'm saying. I know, I'll know, but let's just see what that gets us. Clean as a whistle, like it was never there. Okay, I'm just gonna go for it. You know, I don't really like that, but well. Part of me wants to thicken this up, and can we just move that face? No, doesn't like that at all. what if we does that work? No. Couple of those chamfer removals are no longer there. Yeah, we're gonna have to clean this up quite a bit, but from the top, I kind of like it. I like how that comes in. And I could just make this whole thing wider here. That's an option. Yeah, and we're just playing around. Let me see how it looks like, kind of in the context of everything else here. Come on, little fella. I probably renamed the part and gave it a new UUID when I did the Boolean. You know what? There's probably a better way to fix that, and that's just by, I wonder if it lets you determine which component is the owner. So I wonder if order matters. Can we drag this up? So this was called the tail section. Okay, so basically it made the tail section the owner part. Let's see if that... Perfect. Okay, that works. Good to know. I do kind of like how it just sort of nips around the axle a little bit there. That's kind of... So I'm liking how everything is just kind of like nicely packaged in here. What is that width? I could bring the tail section out wide enough to pick up one extra, kind of come narrow, and then we could just come, yeah, Let's just make it wider all the way out. I do like the little flare, but let's work on that. So what's the best way to do that? Let's roll back here. Let's use our handy little delete face tool. I kind of like this up to this point, and then we'll hide these for a second. Where is that? Fill it coming in. Can I just delete that? Yes. Oh, let's not do that. Let's just get rid of some of these lines, because I want it on the front still. It'd be nice to get those to match up, but we'll fix that later. You know, instead of that, let's just get rid of those. No. No. Let's just move that back a little bit, I think. Just roll it there. Let's move this around. So we're gonna kind of completely encapsulate all that anyway, so. get rid of those chamfers now that they're back out. And then let's do the same. Okay, we're gonna see if we can break a whole bunch of stuff here. And we're just kind of hacking on this right now. We're just combining a couple of different parts and seeing if we can make something we like. If we get it to where we like, we'll go ahead and clean it up a little bit, but where is that? Let's roll. Let's just roll to here. Trying to get rid of this chamfer. Well, it doesn't really matter. Let's just do what we're intending to do here. Let's just kind of rough this out. Oh, that's fascinating. That totally broke something. So let's just step through it, see where we went wrong. Probably about these plugs in. Yeah, that's what's going on there. For some reason that got off. What is going on? Let's just step back to here. That one is correct. Now let's step to here, copying it. There we go. Much better. So now let's do our sketch. So it's just should be symmetric, so we use that. Make that tangent. Mirror this. I'll just use use these features, which we want to keep. Guess we could have mirrored those. is that blue? Okay, I think that will work. We're probably gonna have to re-boolean the snap dot pockets, but that is okay. Trying to think how deep we want to go with this. Let's just extrude that. We're gonna add it to the tail section. Let's just go up to face. Actually, let's go. What does that get us? A little ugly, but we'll keep working at it here. Probably going to break a bunch of stuff in our assembly, but it's alright. Only a few. I'm kind of liking that roughly though. It's it fits kind of with a little bit of the square kind of blocky stuff. And again, we're going to add, we'll probably add some snap dot connectors in here, so we can pick up the wing. Cool. Let's keep plugging away at that. Actually, I wonder, let's just try something dumb. Have to part. Nope, that didn't work. Alright. I was just curious. I'm kind of being very inefficient right now, but just really trying to just kind of rough out what this needs to be. I almost feel like let's just roll back a little bit. Maybe if we get rid of these chamfers too. It'll let us do all of this a little more cleanly. And we'll go back and add them back in once we figure out what the sort of overall aesthetic needs to be. What are we missing? Okay, I've got some ideas. We're getting very close to the point where I'm pretty sure I'm just going to redraw this whole thing, but I kind of like roughly where we're going with this. It'd be kind of cool too. We could bring up the wing. We need to match kind of that angle on some kind of wing side plates. And then again, the cab will come in here, and then we'll do the hood. But kind of want to get this tail section figured out first. Let's see, and actually we've got some parts on the printer, so let's go ahead and check those out. That's our hold down part here. Let's see. I think that's a little off because we bumped the camera. So here we go. Let's throw a couple of snap dots in. Just throw all three in. Do a little disassembly. Actually, let's just take this whole thing apart here, because we're going to use the new struts. Need another link pin connector. No whining, buddy. No whining. Alright, so here's our new connector, and it's going to pick up these two studs and hopefully hold down. Can we get a snap on here? Oh, you know what? I completely missed a major feature that needs to be in there. Let's go edit that. I completely overlooked something. That does happen. We need clearance holes there, otherwise it will never go on. So let's turn our layout pattern on. Let's add those. Okay, let's turn that off. Make these equal. And if we go 5, that should be plenty of clearance, and we're just going to blast that all the way through. That's much better. Dumb move, but that's okay. Let's just go and verify it. There we go. Okay, so we are going to have to reprint this one. That is okay. Delete you. Change the filament. Auto. Those are good. Slice this plate. Print this plate. Send this plate. All right. Gotta love that workflow. Nice and fast. Is that done? Oh. You got the big printer printing some stuff. Let's check on something here real quick. Check on something here real quick. Okay. Okay, so we'll get the part that actually has a chance of working, printing, and back into kind of hacking on this tail section until we get something that we like. Cool. I think let's double check that that's nice. Okay, so that's 5. Alright, we are going to kind of use this as our base, and then we are going to start a new I don't want all the features, so we're only going to use some of these. And let's see what else we need to pick up. I need these locations. Okay, so we'll figure out kind of the fillet and stuff. But we've got all the major pieces in, so now we can kind of construct something anew. Let's go ahead and add. Do I have the layout grid in here? Let's add kind of the other snap dot locations that we want back here. We could make this thing, we could just fill this thing up with them. Although I kind of like having this front zone and then like this rear zone here, and then we'll do some kind of cutout in the middle. So let's use those. And that's our lower one. So let's turn that off. Excellent. Let's just kind of keep that. And I think let's actually just do something more like that. That's going to be square because that'll made up with the cab. Let's see, hold on one second. I think my dog needs to go out. All right, we're back. Let's see. Okay, what's interesting, I would actually like this to be concentric with that snap dot. That'll keep with the system. Oh, seems to be chaos outside. 1 second again. All right. So yeah, so we are just kind of roughing this out, but I want this to be centered. This is the tail section. There we go. The old one kind of came out in a wonky way. Like that. Just make sure everything still matches up with our snap layout. Yep. Okay, so let's just extrude a new thing. Let's call it 2 for now. Let's turn our other tail section on. Looks like 2 people might be watching right now. I don't know who you are. Feel free to say hi in the comments if you'd like. Let's see, maybe we just kind of match that. Cool. So I think what we'll do is we'll extrude all these pockets up. So we can put the snap dots in and then cut. Basically we'll do all the snap dot stuff. Trying to be careful not to add any inadvertent automatic relations. This will also let us, just like that. Throw this in and kind of get a sense of where we need clearance for that axle when the rig is in full bump. Okay, so we're going to select all these. We're going to go E. And there's going to be 9. And so now we can let's see, that's actually cool. Let's change the face there. We're going to extrude that at 5. The other way. So now we've kind of got pockets for our snap dots. Let's rename this so we know what it is. We'll just call this the TBRD01 tail section. And let's go into the assembly. Let's just throw it in there for now so we can start getting a rough idea of what it looks like. just going to throw a quick mate there just to keep it in place. We'll rebuild this assembly. Sorry, that one. Okay, so good. None of our snap dot locations are going to get in the way of the axle. That's mostly what I wanted to double check. So now we can go back in here. We need these. Hold on one second. Okay. So I guess we could actually bring those down too. Okay, but actually, let's jump to the overhead here. And let's install this connector piece that should be working. Let's put some snap dots in it. That's better. And we'll throw our temporary tail section on and cab. Just check the fit up. I think that's pretty good. And just sneaks in and out there. Nice. All right, let's jump back to the CAD. Working on a new tail section here. Kind of hacked away on the old one. I think we'll go in and let's add kind of a perimeter. This one worked pretty well. So it's like a 4 wall thickness. Let's do a new sketch. Let's just try going all the way around and see what we get. Use that and we'll just do an offset. Yeah, I don't really like that. Yeah, I don't know what the best way to do this is. Let's see. I think, I mean, it's not that I don't know the best way to do it. I don't know exactly what we should do here. You know, I kind of like bring that down and kind of up. We could just do a couple straight ribs because we kind of want this to be wings. So maybe let's go on this side. Let's do a new sketch here. Maybe let's kind of Actually, at this point, I almost feel like we just kind of just do something like that, and then we'll add some ribbing. So maybe let's throw in one of those. And then let's just make this easy. Let's just do part pattern. Actually, let's move that into there. I might be able to do that centered. $10mm. Let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, maybe. The other way. Yep. Okay, so we'll just leave those. We can do a subtract, and then we're just going to pick the tools that we want to use. There's those, and then cool. So that gives us all of our snap dot pockets, at least on the top. Let's go ahead and actually, if in theory these should be in the right location. Probably just go in and add those. So now we have all of the snap dot locations we wanted, because we're adding a lot more to this one. So this is for the connection to the cab. This is going to be for our wing or for some other kind of accessory, because unlike the MDRD01 trophy truck kit, we're going to hang the spare tire off the bottom, which you can kind of see here, rather than off the top, because we have plenty of clearance to do it behind the rear axle and enough ground clearance to do it at full bump. So, and then these little slots can pick up our limit straps. Let's just throw in our rough cab. Is that it? It's not at all final, but just kind of a general concept. Come a little wider. So yeah, I think if we do a couple ribs that come down and then kind of back and just straight back, and kind of leave these as sort of almost like a winglet, it kind of sticks out. So that's kind of like if we just took you can almost kind of angle them in. Kind of make this parallel. Can almost bring them in. Maybe tangent? I don't know. Let's see what that looks like. Let's kind of trim this up here. Something like that. I'll kind of deal with these holes a little bit. Sit down, buddy. Hey, Fox. Good girl. Right. Fox. Good boy. Good girl. Yes. Kind of like that. I kind of like how those ribs sort of poke in between all the other stuff that we've got kind of going on down there. And they're not straight. They give just a little bit of a taper. Let's see, actually, how does that work with our spare tire? Oh yeah, plenty of clearance. I mean, if we wanted to be really silly about it, we could come in and add a little support for that. But it's not really, it's not really needed though. So that might be a little extra. Okay. Let's see how much we got. Another half an hour to go today. Making some progress. It's been a little bit slow, but we spent a fair bit of it on a side quest making a nice generator tool for these strut connectors. What? Yes, good girl. Play. I almost wonder if we can kind of thin these up a little bit, maybe. Although we need to keep that, so let's although we could actually get rid of that snap dot. Let's do that here real quick. Kind of liking that. Let's see, so that we're going to have to, oh, well, that's, could kind of thin this whole thing up here. Let's see. Just going to create essentially some geometry so that as we thin this out, we're keeping enough meat for the snap dot pockets. Add an equal relation there. Let's see, so can we now remove 3 millimeters from that and keep our no barking bud. We can, but we're going to have to make those bigger. So Mm-mm. I'm sure there's a less tedious way to do this, but this is what I'm doing right now. So nope. Let's see, we make that 9. Maybe 8. Let's try that. It definitely gets us what we want. Let's see, let's check the other one just to kind of get a diameter. Nope, 9. So excellent. Might not like that. I just want that to not have a sharp edge. You know, it'd be cool. That's what we should do. Instead of having these be parallel, we could also slightly taper those in as well. Like if we were to go see if that breaks everything. Oh, wrong one. Kind of interesting little inversion there. Almost. Okay. It's getting out of hand. We're getting too dirty. We don't know what's going on anymore. Okay. So let's good there. We've made a sketch. Extruded up some ribs. We're going to just going to do it that way. I see what happened. Okay, so I'm actually just gonna do that. There we go. We are back where we want to be. Now I think what we can probably do is go into here. We're just gonna use a little trick where you make that, you keep the line, that way you have the reference, but you just make it construction, and let's see if that does. That does what we want. So now we get our taper. We keep everything else intact except for that. Let's keep fixing this thing. We'll just keep it. Yeah, so I don't like how close that wall is. The slicer will not enjoy that. So I do think we're going to have to ideally kind of add some reinforcement there. Maybe what we do, I know we can do that. Let's kind of add some flare. Kind of like that. What I'm trying to do is just bring this up so it's tangent. Let's do a little. Get rid of that relation. Now we should be able to bring this and that. Why not? There we go. So that now should come in. Tangent with that. So let us fillet these. Oh, not that. Okay, I'm kind of generally liking how that looks. Alright, let's just do some housekeeping stuff on it. We're going to have to, all these snap dot pockets need a 0.4 chamfer. That's the snap dot going easy. We'll round out these kind of once we know a little more where we're at. Probably. Yeah, we're going to need a boss there too. Don't like that though. Okay, well, we're about out of time for the day. For some reason, this square is not centered. I'll get that figured out, because that's not, chasing down some of the bugs is not very interesting to watch. But we will be back again on Monday. So Monday at 8 to noon Pacific time, and we'll be continuing the build of the TBRD01 ClickRigs trophy truck. And yeah, thanks for watching, and I will catch you all later.